Question 4, exercise 10K, page 461. A rocket is fired into the air from a platform which is 1 metre above the ground. The path of the rocket can be modelled by a quadratic function with equation where t is greater than or equal to 0 represents the time in seconds since the rocket took off, and the function represents the height in metres of the rocket above the ground. A, find an expression for the velocity of the rocket at time t. Well, if we want an expression for the velocity, we just take the derivative of that. Okay, so we'll do it over here. We've got y t equals minus 0.2 t squared plus 2t plus 1. Okay, and the derivative of that is minus 0.4 t plus 2. So that's our expression for the velocity. So we can say velocity equals minus 0.4 t plus 2. So we've done A, and now B, the initial velocity. All right, so we'll do that here. The initial velocity, this is B, that's A, right? Okay, so the initial velocity of the rocket is where time is equal to 0. So we put velocity equals minus 0.4 times 0 plus 2. So that must be 2 meters per second would be the initial velocity. Part 2, the maximum height of the rocket. Well, the maximum height of the rocket is where the derivative of this is equal to 0, because that's where the maximum is. We already know that the derivative of this is that. So we equate that to 0 and we find out the value of t, and then once we get t, we put it back into the original function to find the height, because we want the maximum height. So we'll find the value of t, and then we'll put in that and we'll find the height. So let's do that for number 2. So we know that the derivative function is this. We have to equate that to 0, and we've got, and so therefore t equals, be 2 on 0.4, which is 2 over 4 on 10, which is 20 on 4, which is 5, so that's 5 seconds. Remember, the question was the maximum height, so we have to put the 5 seconds back in this one to find the height. Let's do that. So we've got go back to this one, minus 0.2 t squared plus 2t plus 1. We're going to put 5 in here. So we've got minus 0.2, 5 squared, plus 2 times 5 plus 1. Okay, this is minus 0.2 times 25 plus 10 plus 1. Okay, so that's going to equal minus 2 on 10 times 25 plus 11. Well, that's minus 5 plus 11, and so that's 6. And because it's height, in this case it's meters, 6 meters. All right. Okay, for part B, 3, the speed at which the rocket hits the ground. Let's do that one here. Well, where it hits the ground is the roots, or the 0, of this equation. So what we need to do is find the roots of that. We're going to equate it to 0, and we've got minus 0.2 t squared plus 2t plus 1. We're going to use a quadratic formula. We've got t equals minus b, which is minus 2, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times minus 0.2, which is a. It's got minus 2 plus or minus the square root of 4 plus 0.8 all over minus 0.4. That's minus 2 plus or minus the square root of 4.8 over minus 0.4. So we've got two solutions. T equals minus 2 plus the square root of 4.8 all over minus 0.4. And t equals minus 2 minus the square root of 4.8 all over minus 0.4. Okay, so from the GDC, we get this one as equaling minus 0.477, 3 significant figures, but this is the one we're interested in, and this is 10.4. Let's just write it up. 477,226. 226. Okay, now they've told us that t is greater than 0, so we're going to exclude that one. This is one we're interested in, but that's only given us the time. The question was the speed. So we have to put this back in the velocity expression, which is that one, or this one here we got from A. So let's do that. V equals minus 0.4 t plus 2 minus 0.4 times 10.477226 plus 2, and that equals minus 2.19. 2.19 to 3 significant figures. And that's in meters per second.